Hey everybody, it's Ken. In this video, I want to show you some formulas for indefinite integrals. And the thing that I want to impress upon you is that whenever you can take the derivative of something, that gives you a formula for an integral. So for instance, check this out. So let's look at the function x to the n plus 1 over n plus 1, and for any n not equal to -1, right? If it's -1, you're dividing by 0, that can't happen, but for any other n, you can look at that function. Let's take its derivative. So in Leibniz notation, d over dx. And then the power rule tells us that I can bring down that exponent, n plus 1, and then n plus 1 minus 1 gives me x to the n, and divide by the constant. Formally speaking, you could take the constant outside and then use the power rule, but we don't have to be sort of that pedantic about it. And then the n plus 1s cancel out, and I'm just left with x to the n. So this gives me an integral formula because it tells me that an antiderivative for x to the n is x to the n plus 1 over n plus 1. And I can rewrite that by saying that the indefinite integral of x to the n is going to be x to the n plus 1 over n plus 1 plus constant c. And that's a really nice formula to have. And it works for any n, whether or not it's an integer. It just can't be -1. If n is equal to -1, you might ask, what's the antiderivative of x to the -1? What's the antiderivative of 1 over x? In a previous video, we saw that was natural log of absolute value of x plus c, whenever x is not equal to 0. So let's show a couple more. So you know that the derivative, switching to Newton's notation, you know the derivative of sine of x is cosine of x. So that tells you that the antiderivative, or the indefinite integral of cosine of x, to be sine of x plus c. And so that's going to give you formulas for all the other trig functions. For instance, you know that the derivative of tangent of x is equal to, if I remember right, that's secant squared, right? Secant squared of x. So that tells you that tangent of x is an antiderivative of secant squared of x. In other words, indefinite integral secant squared of x dx equals tangent of x plus c. What's another one? Let's take the derivative of arctangent. We also see it written tangent to the -1 of x. That notation's a little dangerous. I don't mean 1 over tangent of x. I don't mean the reciprocal. This is notation for the inverse when you restrict it, x from -pi over 2 to pi over 2. It's also called arctangent of x, but you see it written that way sometimes. And the derivative of this, if you remember, we did one of these right triangle arguments, and we saw that this was equal to 1 over 1 plus x squared. And so that gives us a really nice formula, which is pretty cool. If you want to take the indefinite integral of 1 over 1 plus x squared, then that's just going to be nothing but arctangent of x, or tangent inverse of x plus c. And when you know this integral, later on in Calculus 2, you're going to be on your way towards being able to take the antiderivative or integral of any rational function, any ratio of two polynomials. There's a general technique called the method of partial fractions that lets you do that. This is like one of the first steps towards, towards that goal. And for all of the other inverse trig functions, right, you can remember their derivatives or look them up, and then that'll tell you, respectively, like the antiderivative of of the right-hand sides of all of those. So, like, once again, the general idea you want to have is whenever you can take a derivative, that gives you a formula for an antiderivative. So everything that you've learned from the course so far now applies to give you a basically big list of indefinite integrals.